can measure temperature. We saw how we can measure temperature. And two ways we saw. Okay. Two ways we saw. Two types of thermometers we saw. Yesterday we discussed about the clinical thermometer. Today we will be discussing about the laboratory thermometer. Okay. About the laboratory thermometer. Now, laboratory thermometer looks very, interesting. Okay. It's a long, thin tube, a long, a very long and very thin glass tube, totally made of glass. Okay. And it measures the temperature of chemicals. Okay. It measures the temperature of chemicals. So in science labs, chemistry labs, we have laboratory thermometer. Okay. The clinical one measures human body temperature. The laboratory one measures the temperature of other objects, such as chemicals. It consists of a long, narrow glass tube. The lower end of the tube is like a bulb, and it contains mercury or alcohol, and its upper end is sealed. The glass tube is kept in an, the glass tube is kept in ice cubes. The point in the tube where mercury becomes steady after getting cooled is marked as zero. Okay. When mercury comes in a position where it is ready to mark the temperature of chemicals and all, that point is known as 0 degrees Celsius. Now we can keep the tube in boiling water, okay, in the steam of boiling water, and mercury starts to expand inside the tube. The point in the tube where mercury becomes steady, means where mercury rises and becomes steady, is marked as 100 degrees Celsius. Okay, the intervening space between the 2 points, that is 0 degree to 100 degree, is divided into 100 equal parts. Thus, the measure of one small division is 1 degree C. Okay, the range that at which laboratory thermometer measures temperature is minus 10 degrees Celsius to 110 degrees Celsius. Now look at the difference. Look at the difference. A clinical thermometer will measure 35 degrees Celsius to 42 degrees Celsius only, whereas a laboratory thermometer will measure from minus 10 degrees Celsius to 110 degrees Celsius. Imagine how hot. Okay, imagine how great temperatures it can record. Okay, it can measure. So that is why we use it to measure temperatures of boiling liquids, boiling hot water, and you can say chemicals and all. Okay, so that is a clinical thermometer. Sorry, laboratory thermometer. Any doubts in laboratory thermometer? Hello, Amrita. Good morning.
Hello, ma'am. Good morning.
Now, any questions related to laboratory thermometer?
Ma'am,
Yes, Hannah.
ma'am, in laboratory thermometer, ma'am, does it only measure in Celsius?
Does it only measure in Celsius? Hannah, a Celsius can be converted into Fahrenheit, and the Fahrenheit can be converted into Celsius based on what we want. Okay. For example, if we measure it in Celsius with a laboratory thermometer, you can convert it to Fahrenheit. Okay. So it will give us Fahrenheit also. It will give us Fahrenheit also. Similarly, if we try to measure in Fahrenheit, we can convert it to Celsius. So it will give us Celsius. So conversion between Fahrenheit and Celsius can take place. Now, precautions to take while using a laboratory thermometer. A laboratory thermometer should be kept upright while using straight. Okay, straight. And the bulb should be surrounded from all sides by the substance of which temperature is to be measured. Means if you are measuring any liquid substance, then the bulb, means the front part of the thermometer, should be surrounded by that substance from all the sides. Okay, then the bulb should not touch the walls of the container. Okay, if you're putting it in some container, it should not touch the walls, but it should be like this. So there is like a stand used in laboratories. So on that stand, you place the burner, and on the burner, you heat up the chemical or the water, and then you use another stand to hold the thermometer like that in the liquid. Okay, I've seen it. So it is used like this to hold the thermometer in the liquid. So it doesn't touch on the side and you don't have to hold it. It just goes in the center of the container. Okay, it just goes in the center of the container. So we use a stand to hold it. Hello, Eva. Good morning.
Ma'am, good morning.
Okay, so in this question, 10.1 is homework. Okay, this I gave yesterday only. 10.1 I gave yesterday. Okay, now propagation of heat. Okay, propagation means transfer. Transfer, or you can say movement. Okay, transfer. Transfer means what? When something goes from one place to another, that means transfer. Okay, so transfer or movement of heat. Now, what happens when we pour hot tea in an empty glass of steel? Okay, the glass will become hot when we pour hot tea in a glass of steel. Okay, the glass will quickly become hot. What happens when a metallic rod is heated near its one end? If you take a metallic rod and heat it from the one end, you will observe that after some time, this end will become hot as well. Okay, the example I gave of the spoon. When you hold a spoon on fire, first it will heat up the front part of the spoon, and then slowly it will reach the rod of the spoon also, that part where you are holding it. Okay, the whole of it will be heated. Okay, and when we are keeping the hot tea filled mug for some time, the tea will cool down. Okay, the tea will cool down, but the mug will be warm. Have you ever observed this? The tea will cool down, but the cup is hot. Okay, if you observe this phenomena, then when we are standing at a distance in front of a fire, we after some time start getting warm. In winters, if you have sat near a fireplace, okay, a bonfire, a fireplace at Christmas, New Year, you must feel that after some time you also start getting warm, right? You also start getting warm. So these things show that heat flows from one object to another. Okay, heat flows from one object to another, from one place to another, from one part of the object to another. Okay. In when you are sitting near the fire, the heat will flow towards your body or in your body. Okay. And when you're holding a spoon on the fire, the heat will flow in the spoon from one end to another. Okay, from one end to another. Okay. So this is the process of transfer or displacement of heat. This is the process of transfer or displacement of heat known as propagation of heat. Okay, this is known as propagation of heat, transfer of heat. Okay, learn the definition and also learn some examples like this. Okay, you can learn some examples and the definition. Now, how does this heat propagate or how this heat move or transfers? We will see. Okay, uh, there is an activity. Take two rectangular pieces of iron or any metal of the same size. Heat one of the pieces for a while. Now, place the second piece above or close to the hotter piece. After some time, find the temperature of both the pieces. okay, you will observe that the temperature of second piece has increased. What does this conclude? Okay. Um, let's see. Okay. For example, sometimes when I'm cooking, okay, when I'm cooking, maybe a vegetable or maybe some lentils, okay, I forget and I need that big spoon that we use for stirring in the container only. Okay, in the container only. So what happens is when I left the spoon in the container, now it was full. It was full because I was holding it. Okay, and it was full only. But after some time, when I come, okay, and want to take it out, it becomes hot. Okay, it becomes hot. Why? Why is it so? Transfer of heat from the container to the spoon, stirring spoon. Okay, so something similar activity is taking place here. They have heated up one block of iron and they have placed it near another block of iron. After some time, you will find that that another block will be high in temperature. Okay, the temperature of that another block will increase. This shows that propagation propagation of heat between two bodies or two objects is due to temperature difference. When there is a temperature difference between two objects, the heat transfers. Okay, and the heat always transfers from a hotter object to a colder object. Very important. The heat always transfers from a hotter object to a colder object. Okay, so this is why propagation of heat happens or how propagation of heat takes place. Okay, one more activity is that dip one end of the spoon in of steel in boiling water. What happens if you keep holding the other end? The other end becomes gradually very hot due to heat. Okay, now each substance is made up of molecules, like I explained you. Every substance is made up of molecules. The temperature of the tip of spoon, which is in boiling water, increases. Hot molecules, hot molecules transfer their heat to the neighbor molecules. Okay. See, some molecules are present here. Okay, and some molecules are present here above. Okay. So as this area becomes hot, okay, it will transfer the heat slowly to the upper molecule. Okay, the heat will be transferred, passed on to the neighbor molecule. It will say, why should I bear all the heat? Some of heat I will transfer to my neighbor also. Okay, so the molecules transfer some heat to the neighbor molecules, then to the neighbor molecules, and so on. The object keeps becoming heated up more and more. Okay. Um, Thus, the heat reaches the end of less temperature from the end of the higher temperature. So, from higher temperature, this point is higher temperature, and this point is lower temperature. Okay, so slowly, the heat reaches from the point of higher temperature to the point of lower temperature. Okay, this method of heat is called conduction. This method of heat is called conduction. Okay, conduction. Conduction of, you must have heard this term a lot. Good conductors, conduction. This is conduction. Okay, now one activity is that heat water in a small pan or a beaker. Collect some articles such as a steel spoon, plastic scale, pencil, metallic rod, etc. Dip one in the piece of these articles in hot water and wait for a few minutes. Touch the other end and write your observation. Plastic scale, which material? Plastic. Pencil, wood. Metallic rod, metal. Okay. Can you all tell me what will be the observation? Will the other end of the plastic scale get heated up?
No, ma'am.
No. Will the wood get heated up? Italic verb?
Yes.
Yeah. So, wood because heat does not travel through wood. Okay, that is why while cooking we use wooden spoons, wooden spatula, wooden spoons to make food. Okay, because it does not get heated up and it is good for certain types of utensils also. Wooden spoons and all. Okay, so that is there. Now, the materials which allow heat to pass through them easily. Materials which allow heat to pass through them easily are called conductors of heat. Okay, these are called conductors of heat. For example, aluminum, iron, and copper. Okay, these are all conductors of heat. The materials which do not allow heat to pass through them easily, those materials through which heat does not pass, means the heat molecules will not pass the heat to the neighbor and it does not get heated up. These are known as insulators. Okay, bad conductors or insulators of heat. These are called insulators of heat. For example, plastic and wood. So question may come, what is the difference between conductors and insulators? So you can write those materials which allow heat to pass through them easily are conductors of heat. Those materials which do not allow heat to pass through them are called insulators of heat. Okay, do examples also. Please do examples also. Okay, any questions still here? Any questions still here in the concept propagation of heat? No? Okay, then one more activity is here. Take a tumbler, fill it with water. Wait till the water in the flask is filled. Place a crystal of potassium permanganate at the bottom of the flask gently. Now heat the tumbler slowly. Potassium permanganate is used. Observe the colored streams arising from the surface of water. What do you see? When water is heated, the water near the flame gets hot, gets hot. Hot water rises up and cold water from the side comes to take its place. Okay, this water also gets hot and rises. Water from the side moves down. Okay, this process continues till the whole water gets heated. Okay, this mode of heat transfer is known as convection. This mode of heat transfer is known as convection. Okay, convection is used in chimneys and ventilators. Okay, convections are used in chimney and ventilators. We have a video on convection to show you convection. There are three methods of heat transfer in your lesson: conduction, convection, and radiation. Okay, conduction, convection, and radiation. I'll show you a video on that.
Heat transfer is the process by which heat flows from one object or system to another due to temperature differences between the two. There are three main ways by which heat transfer occurs: conduction, convection, and radiation. You can heat only one side of a steel plate on a cooktop, yet the entire plate will get hot. That's an example of heat transfer due to conduction. All the water inside a container becomes hot when you only apply heat to the bottom of that container, which is a classic example of convection. We all experience the scorching heat of the sun when we step out of the house on a hot summer day. Why is that? Radiation. Similarly, you may have noticed that when you sit in front of an incandescent lamp for too long, it feels warmer than the rest of the dark room. That's also because the lamp emitting heat as radiation. Now, the interesting thing about radiation is that it doesn't require any kind of contact between the heat source and the object, unlike conduction and convection, both of which require matter to transfer heat. Heat transfer is the process by which heat
Did you understand, or do you want to watch one more video? One more video we can see.
Ma'am, I didn't understand what is convention.
Let's check out one more video.
Thermal energy moves in three main ways: conduction, convection, and radiation. The movement of heat within a solid object is called conduction. Conduction also occurs when objects are touching. Look at the kettle on the stove. Heat from the flame moves through the metal of the kettle to the water in contact with it inside. This is an example of heat conduction. Butter melting on a fry pan is another example of heat conduction. When you lick an ice cream, it feels cold because heat conducts from your tongue to the ice cream. The movement of heat in liquids and gases is called convection. The air in a hot air balloon is heated by the burner and rises up inside the balloon. As the hot air rises, the cooler air falls and creates a current within the balloon. The convection current causes thermal energy in the air to spread through the balloon. On a hot day, you might cool down a room with an air conditioner. The cold air that blows out from the air conditioner circulates around the room and creates convection currents. Heat moves from the warmer air to the colder air, which makes the air in the room cooler. Cool, hey? For the thermal energy to move by conduction and convection, it must travel through matter. Between the sun and the earth is empty space. How does the heat from the sun warm the earth and other planets in the solar system? The answer is radiation. Radiation is the transfer of energy through electromagnetic waves. Look at the man warming by the fireplace. The heat from the fire warms the air in the room through convection. However, the man also receives warmth from the fire directly through radiation. The warmth you feel when you place your hands near an electric heater or a campfire are examples of heat in the form of radiation. We can observe conduction, convection, and radiation when water in a kettle is heated. Thermal energy moves through the metal to the water by conduction. Thermal energy moves around the water through convection. And finally, the heat leaves the kettle and is transferred to its surroundings by radiation. I hope you had fun learning about heat. See you next time.
Alright. So, where were we? Yeah. Conduction, convection, and radiation. Now, what happens in conduction? Heat transfers through when base of something touches fire. Okay. When the base of something, okay, such as a vessel, a container, touches fire, the heat transfers through and makes whatever the content is inside that vessel hot. Okay. Conduction. That is known as conduction. Okay. When you are heating up any vessel, any container, kettle, anything, and the base of it is becoming hot, and that transfers the heat through the base into the food. That is conduction. What happens in convection? in convection, there is movement of water. Okay, movement of water. The liquids which are heated up, okay, they rise, and the denser liquids they settle. Okay, rise, settle, rise, settle. So this creates a movement in the molecules. This creates a movement in the molecules, and therefore heat transfers between them. Okay, when this movement is happening, energy is released, and heat is, moved in all of that liquid. That process is known as convection. Okay, convection. And then radiation. What happens in radiation? Radiation is very simple. Then, when heat will reach us without any source in between, okay, when the heat can directly reach us, that is known as radiation. Okay, there is no medium. There is no medium such as air in most part of the space between the Earth and Sun. Therefore, from the Sun, the heat comes to us by another process called radiation. Okay, what is radiation? Transfer of heat that does not need any medium. Okay, transfer of heat when we do not need any medium is radiation. When you are sitting in front of a heater, from the heater directly the warmth will come to you, right? From the heater, you will directly feel the warmth. Okay, that is also an example of radiation. So three methods of heat transfer you have to prepare: conduction, convection, radiation. Okay. Any doubt in conduction, convection, and radiation now? Hope it is clear.
Ma'am,
Yes, Hannah.
ma'am, if the warmth we get by the sun and the warmth we get by the heater, electric heater, ma'am, is radiation, then how is the cold air we receive by AC convention, ma'am?
How the cold that we get by AC is convection. That's what you are asking. Because when we are getting cold from AC now, the change of air is continuously happening. Okay, the air of your room is being replaced. Okay, the air of your room moves around, replacing. Okay, the hot air is replaced by the colder air. Okay, it is turned to colder air, and it is continuously moving. Okay, it is continuously moving, and due to this movement, the molecules pass on cold, and your room gets cold. Okay, so because whenever there is movement in the molecules, either in air or water, it is convection. Okay, movement of molecules either in air or water is convection. Whereas when direct heat transfer is there, it is radiation. Sun does not need molecules to give us heat to burn us. It can just burn us directly. Okay, so that directly is radiation. Whereas AC air conditioner needs molecules. Okay, because the circulation of air is taking place. That is why AC is an example of convection. Sun is an example of radiation. Okay. Now our body too gives heat to the surroundings and receives heat from it by the radiation. Okay. Us, we people also transfer of heat takes place. Okay, in us, and we give out. We receive heat from radiation. Okay, and a hot utensil that we keep away from the flame cools down because it transfers the heat to the surrounding by radiation. Okay. When you take an object, remove it from the flame and place it down, okay, it will become cool because um, it will release its heat. It will release its heat into the surrounding. Okay, that is also an example of radiation. Getting heat from straight the source and releasing the heat into the surrounding, both is known as radiation. Okay, it means that all hot bodies radiate heat. Okay, all hot bodies radiate heat. When this heat falls on some object, a part of it is absorbed and a part of it is reflected. This you know, right? When heat falls on any object, some of it is absorbed by the object, some of it gets reflected. Okay, some of it absorbed, some of it reflects. Absorption reflection we will discuss more in the light chapter. Okay, when I'll do the light chapter with you, we will see deeply how reflection and everything takes place. Okay, now the temperature of the object also increases due to the absorbed part of the heat. Okay, now I said that some heat is absorbed, some heat is reflected. So due to this absorbed heat, the temperature of the body is also um, increased. Okay, the temperature of the body also increases. So that is why we know that why we use an umbrella when we go out in the sun. Okay, so that we can shield ourselves from the rays. Okay, so that we can shield ourselves from the radiation, so that the umbrella can absorb the heat and reflect it, and then we are safe. Okay, but we may look like a fool, but then that's okay. Whatever serves us best. Okay, so then hope you understood. Hope you understood. Um, Transfer of heat from our body into the environment. Hope you understood that. Yeah. Land breeze and sea breeze. Okay. Now, there is a phenomenon. There is a phenomenon about the land and the sea. Okay. A cycle that repeats itself every day. Okay, let's see what is that. Now, the people living in the coastal areas, means near the water bodies, experience an interesting phenomenon. During the day, the land gets heated faster than the water. Okay, during the day, in the daytime, the land becomes hot faster than the water. The air over the land becomes hot and rises up. The air that is in the land, because the straight sun rays are straight falling on the land, so it will become hot faster. And the hot air, when the air becomes hot, it rises up. Okay, the air always, when it becomes hot, it rises up. When you're boiling something, steam goes up. Okay, whenever the air becomes hot, it rises up. The cooler air from the sea, the cooler air from the sea rushes in the land to take its place. Okay, to take its place. So this is the warm air from the land that rises up, and the cool air from the sea comes to take its place. Okay, so this breeze that is coming from the sea is called sea breeze. Okay, this is known as sea breeze. On the other hand, in the night, in the night, the land cools down more quickly. The land cools down more quickly than the sea. Okay, so the cool air from the land, now because the land is cooling faster than the sea night also, the cool air from the land goes in the sea. Okay, and because now the sea was hot, the hot air from the sea comes to take its place. Okay, just give me 1 minute. Hello. So now in the night, the land is cooler. So the cold air from the land goes to the sea. Okay. And the hot air from the sea will come to the land. Opposite. Okay. So this breeze, okay, the cool air from the land now that is moving in the sea is known as land breeze. Okay. It is known as land breeze. Okay. Understood how sea breeze and land breeze takes place? Yeah. How sea breeze and land breeze is taking place? You must have heard from people living near water bodies, now when cold air comes, oh, it's sea breeze and all. Oh, it's sea breeze. Ever heard that from somebody living near the sea? Sea breeze is coming. So that is sea breeze when the cool air from the sea is coming to the land and the hot air from the land is rising up. Sea breeze. Okay. When the um when the cool air from the land is going to the sea, and when the hot air from the sea is coming to the land. Okay? All right. So we will stop here for today. We are going to stop here for today. I'm not giving any science homework today because I will give a lot of math homework. Okay, so no science homework and 5 minutes break for you, and then I will see you for math. Okay, let's begin. With your answers, all of you.
1 second, ma'am.
Now, I was seeing the index page as to what new chapter we should start today. Okay, so check that out with me. Now, in the chapter, we are done with lesson 1, 2. I think we are still left with the third chapter, right? The third chapter, did we do the third chapter?
No.
No, right? We did fourth chapter, Introduction to Algebra, fifth chapter, Algebraic Expression and Operation. Then we did eighth chapter, Percentage and its application. Then 10, 11, 12, and 13 we did fundamental geometrical concepts, angles and parallel lines I taught you, triangles and its types we did, and quadrilaterals and its types we did. Okay. Now, circle, did we do circle also or circle is pending? Yes, Eva.
What about the test results on the paper?
Test results. The test results you will get today evening. For sure.
Excuse me, ma'am.
Yes, Hannah.
Ma'am, my system was glitching, so I rejoined, ma'am. Is the chapter done, ma'am? Percentage and its applications.
Percentage and its application is done, Hannah. You just have to do the homework that I am giving you. Okay. And ask doubts. That's your only work. Do homework, ask questions. Do homework, ask questions. Okay. Otherwise, the chapter is done. All the concepts and everything is done already. Yes, Abhijah.
Ma'am, could you create my test paper as well for math? Chapter
Your
13.
what? Your test, Abhijah? Yes, I think I
Yes.
got your test. Yeah. As far as I remember, I got your test. And today evening, the results will also come. Okay. I was busy the last few days with some work. So, like, only just, it just got finished last night. So, today I'll check all your papers and results will be out. Okay. Now I am thinking we can start with the third chapter, square root, cube, and cube root. Okay. Um, seventh chapter I will do later on. Okay, because we just finished a whole lot lengthy and heavy chapter. I don't want to start another lengthy chapter. We want to do something a little bit more on the easy side first, and then we'll move on to some chapters such as ratio proportion, the ninth chapter and all. Okay. Or we can start 14th chapter. Okay. You have choice. Third chapter or 14th chapter. Any one of it we can start today. Suggestion. 14. Okay, Eva. Anybody else?
Circle, ma'am.
Ma'am,
Partial. 14. Okay. Okay. So let's start with the 14th chapter, circle. I was also waiting for Joshua. I don't know if Joshua is coming. Fourteenth chapter, circle, is just like the name suggests about circle. Okay. In this chapter, we are going to talk about a circle. We are going to talk about parts of a circle. We are going to talk about various, uh, you know, divisions of a circle. Some parts some divisions of the circle. Okay, and some questions are also there. Just a few questions are also there. So let's see, and let's begin with circles. And the first topic for you is parts and elements of a circle. Parts and elements of a circle. Okay. Now, when we make a circle, okay, when we make a circle, we usually make a circle using a compass. Okay. We usually make a circle using a compass. And the point that is found at the center of the circle, where we keep the compass, okay, is known as center. This point is known as center.
Ma'am, should we also do the diagram?
You don't have to do this diagram, but the diagrams that will come now, you have to. Thank you. Okay. Yes.
So we have to copy them down, ma'am.
Yes, you have to copy them. Okay. Now you can say that a circle is a collection of all the points in a plane which are equidistant from a fixed point. Okay, which are equidistant from a fixed point. What does that mean? What does that mean? Look at another diagram. Now in this diagram, I will mark a center point. Okay, I will mark a center point. Hope you can see the center point. Okay, now I will draw some lines. I will draw some lines from the center point to the boundary of the circle. From the center to the boundary of the circle, I will draw some lines. Okay, what is this or what am I doing? I am showing you that when we draw lines, okay, from the center of a circle to different points on the boundary of the circle, it is known as a radius. Okay, it is known as the radius. I will mark the center O points and I will mark them A, B, C, and D points. Okay. Now I will write the definitions below. Distance between the center of the circle and any point on the circle and any point on the circle. . is called radius of the circle.
Ma'am, should we copy this one?
Yes, you have to copy this. Okay, now in this uh, circle, what are the radius? What are the radius? Radius are four that I have marked: OA, OB. You can write example dash OA, OB, OC, and OD. Okay, OA, OB, OC, and OD are four radiuses that I have marked in the circle. You can write them as examples. And the length of OA, OB, OC, and OD are all same. Okay, the measurement of all the radius in a circle is always same. Okay, because no matter where you from, like you start from the center, and no matter where you put the line on the outer boundary, there will always be same distance between the center point and the outer boundary. Okay, from any part of the circle, it will be the same distance. It will be at the same distance. So that is um, known as a radius, and the radius, no matter where you put it, they have all they all have the same measurement. Now we will talk about what is about this boundary of a circle. Okay, about this boundary of a circle. You can see this boundary. Hmm, Boundary. This boundary is called circumference. This boundary is known as circumference. Okay. Measurement of the boundary. Measurement of the boundary of a circle is called its circumference. Okay. Is known as circumference. Finish circumference and then let me know. So I will clear everything and we'll start with something else.
Done, ma'am.
Okay. Okay.
Done, ma'am.
Okay. Rose and Hannah.
Ma'am.
Okay. The next thing that we are going to discuss is a chord, a chord in a circle. Okay, a chord in a circle. Now, when you are making a line, okay, in a circle from any 2 points, okay, from any 2 points, but it is not going through the center. You are making the line, but it's not going through the center. But anywhere else apart from the center is called chord. Okay, is called chord. Wherein definition, line segment joining 2 points on a circle is called the chord of the circle. Okay, let's name the chord A, B, A, B. 2 points are there. Now, why have I written line segment? Line segment because it has a fixed length. A chord has a fixed length. Okay, that is why a line segment joining 2 points in a circle. Yes, Aditya,
Ma'am, so a chord is a line segment joining 2 points on a circle without going through the center, right?
without going through the center. Yes, that's right. It does not start from the center or it does not pass from the center. Okay, that is a chord.
Ma'am,
Yes, yes, Johanna.
so the line in the circle AB is a chord.
Yes, AB is the chord. Okay, example, AB, chord. Okay, AB is the chord. Now, one more thing. One more thing. Okay. Now, there is one chord. Okay, there is one chord that passes through the center. Okay? There is one chord. Ma'am, you just said that a chord does
Ma'am,
not pass
diameter.
through. Yes, diameter. Okay. So there is one chord that actually passes through your circle known as the diameter. How does it, what does it look like? See, this is the center. Okay, I'll make it a little bit more bigger. Center. And we'll make a line. That is going through the center. Okay, making a line that is going through the center. Okay, this is known as diameter. This is known as diameter. A chord passing through the center of a circle is called the diameter. It is called the diameter. Now, there are some interesting facts about the diameter. Yes, Hannah, question you have?
Ma'am, just clarification. So, ma'am, a diameter divides a circle into two equal parts.
Yes, Hannah. Yes, that is correct. A diameter divides the circle into two equal parts, no matter from where you are putting a diameter. No matter from where you are putting a diameter, you can put it from here, here, or from like straight or slant or side, okay, diagonal, vertical, horizontal, diagonal, anywhere you put a diameter, it will always divide the circle into two parts. Okay, that is fact number one. Fact two is that diameter is always double of the radius. Okay, now this is very simple. See, we know that radius means from the center to the boundary, right? That is radius. From the center to the boundary, this much is radius. Yes. And diameter is what? From the center to this side of the boundary and center to that side of the boundary, the full thing. Okay, the full thing. So that is why diameter is double of the radius. If radius is 2 centimeters, diameter 4 centimeters. Radius is 4 centimeter, diameter 8 centimeters. Okay, so diameter is always double of the radius. Diameter is equal to 2 into radius. Okay, diameter is equal to 2 multiplied by the radius because it is 2 times the radius. Alright. And the diameter always divides the circle into two equal halves. Two equal halves. Okay. Then after we have after diameter, we have arc. Okay, we have something called as an arc. Now what is an arc? We'll draw a circle and see. This is my circle. And in the circle, I will mark 2 points. Any 2 points. For example, here. Okay. A and D. Okay. A and D. So, then I will count this part of the circumference. And I will count this part of the circumference from A to D. It is called an arc. This part of the circumference from A to D is called an arc. Okay, this is an arc. Now, some what if these also there? What if these also there? Okay, so I can say that ABC is an arc. Okay, ABC is one arc, ABC is one arc, and AD is also another arc. Okay, AD is also another arc. The black part. You can see the black part. Okay, a part of circumference is called an arc. Example, we have arc ABC and AD. How to represent them like this? Okay, we write the names and put a arc on top. So this represents arc. Okay, the symbol represents arc.
Ma'am,
Yeah, yeah.
ma'am, where is ABC? Where is the C point in this circle, ma'am?
Oh, sorry, not C. I mean ABD. Mistakenly wrote C. It is AB and D. ABD and AD. AD is the black arc. ABD is the red arc. Okay, so this is
Um,
about arc. Yes, Hannah.
Ma'am, but both of them are the same one, right, ma'am?
On the same circle. Yes. One is this part of the circle. One is this part of the circle. Okay, but on the same circle. So yes, 2, 3 arcs can be made on the same circle. That's fine. Yes, Johanna.
How about A and B?
A and B. Yes, A and B can also be considered an arc. Okay, so these are all arcs. Now, tomorrow we will talk about sectors, segments, semicircles, and how to draw a circle and how to calculate radius and diameter. Okay, those are the topics we will discuss further. What's the sector? What's the segment? What's the semicircle? How to calculate the radius and diameter? Okay, so that's it for you today. And I'll send you the homework in the group, and I'll be seeing you tomorrow. Okay, have a good day. Bye.
Hi, ma'am. Thank you, ma'am.
Thank you, ma'am.
Bye, ma'am. Thank you, ma'am.
Bye.